Think of software architecture as city planning. You wouldn't build skyscrapers before laying power lines and roads. Design principles and architectural patterns play that same foundational role in software. They guide how parts connect, how change flows, and how teams grow without collapsing under complexity. When development follows intentional structure, engineers stop firefighting and start innovating. Technical debt shrinks, scalability expands, and the system stays healthy as it evolves. In this session, we'll explore how deliberate design choices turn code bases from fragile prototypes into resilient, future-ready platforms built to last. When software grows without structure, it begins to rot from the inside out. Unstructured design decisions might seem efficient in the moment. Just one quick fix, one extra dependency. But every shortcut adds invisible weight. Over time, that weight becomes technical debt. The team feels it as design fatigue, constantly solving the same problems in slightly different ways. Modules start depending on each other in unpredictable loops. Changing one feature breaks three others. New developers hesitate to touch the code, afraid of unintended consequences. Architectural complexity is like tangled wiring in an old building. It still works, but every repair risks a blackout. Without clear design patterns or shared principles, maintainability suffers. Fixing a bug or adding a feature becomes a gamble instead of a process. Scalability shrinks because the system can't adapt cleanly to new demands. Successful teams recognize this early and standardize how decisions are made. They document, review, and evolve their architecture deliberately, turning ad hoc creativity into structured innovation. The payoff is enormous: less rework, cleaner collaboration, and systems that can grow with confidence rather than fragility. A truly robust system doesn't rely on heroic developers. It relies on disciplined processes. Establishing a systematic approach to software design means embedding reflection and feedback into the fabric of development. Start with architectural reviews. These regular checkpoints aren't about bureaucracy. They're alignment sessions that ensure design decisions support the system's evolving goals. They document trade-offs, record rationale, and prevent divergence. Next, use automated adherence checks. Modern tools can flag violations of design principles, ensuring that every new module respects established patterns. This automation removes guesswork and saves human attention for higher-level reasoning. Layer on system health dashboards that track metrics like build stability, test coverage, and performance. When visibility becomes routine, teams catch decay before it spreads. Finally, integrate continuous improvement loops through retrospectives and postmortems. Each project leaves behind lessons, successes to replicate, failures to learn from. By feeding those insights back into the next cycle, your design principles evolve with reality instead of against it. The result is a living architecture, resilient, scalable, and continuously improving, much like an organism that learns with every iteration. Great architecture isn't rigid, it's modular. Modularity allows teams to innovate locally without breaking the global system. The solid principles provide the scaffolding for that flexibility. Each module should serve a single responsibility, clear enough that its purpose is never in question. Systems that follow this rule are easier to test, refactor, and extend. Next, the open-close principle. Your code should be open for extension, but closed for modification. This means you add functionality without rewriting stable parts, like adding new floors to a sturdy foundation. Liskov substitution ensures that subtypes can replace their base types seamlessly, keeping components interchangeable. Interface segregation reminds us not to force modules to depend on methods they don't use, and dependency inversion flips the hierarchy. High-level modules depend on abstractions, not implementations. Beyond the code itself, regular reviews act as architectural hygiene. They surface small issues before they snowball into costly refactors. Clear documentation, design decisions, diagrams, and APIs serves as the shared memory of your system. Together, These practices transform development from a reactive scramble into an elegant collaboration where each component knows its role and plays it well. If you can't measure your system's health, you can't improve it. Robust design isn't guesswork. It's guided by metrics that reveal how well your architecture is holding up. Start with design principle adherence. A 90% compliance rate means your modules follow the established patterns that keep the system stable and predictable. Next, code quality index, a measure of readability, maintainability, and adherence to standards. A score above 95% isn't just a vanity number. It's a reflection of how easy your system is to understand and evolve. Look at your module decoupling score. An 8 out of 10 indicates your components are independent enough to evolve without friction, minimizing cascade failures when change occurs. Finally, test coverage, at least 80%, ensures that your code base can be modified with confidence. Each metric tells part of the story, but together they paint a picture of system resilience. The key is consistency. Regularly review these metrics as part of your design rhythm. Use trends to guide refactoring priorities and validate architectural choices. Numbers don't replace judgment, but they anchor intuition in evidence. Healthy systems are transparent. They show their pulse clearly, allowing teams to act before performance dips into decay. Every principle we've discussed, modularity, standardization, measurement, serves one purpose: building systems that last. Architectural patterns don't cage creativity, they protect it. By reducing mental noise and preventing chaos, they free developers to focus on innovation. A well-designed framework turns maintenance into mastery, channeling effort toward progress instead of repair. When structure is clear, teams move faster without breaking things. Cognitive load drops, quality rises, and collaboration feels natural. That's the quiet power of disciplined design. It sustains momentum instead of draining it. In our next session, we'll translate these ideas into concrete code structures that evolve with your product. For now, look at your current system. Where does complexity creep in, and what can be simplified? Each small refinement today becomes tomorrow's foundation for resilience.